Okay, so let's get started with our first topic here. So just let me give some introduction to the contents, what exactly we do here. So initially we start with IP addressing, that is what we'll do in this class here. And once we have some basic understanding on IP addressing and the versions, we get into some advanced IP addressing, we call it as subnetting. And then we'll have some basic understanding on OSI reference model and TCP/IP models, how exactly these models describe the network communication. So then we can get into some introduction to routers, where we'll see what is a router, what are the different components of the router, different ports of the router, and how the connectivity is established, different models of the routers. And then we see some different modes of the routers with including some basic commands. So mostly here in this part we'll start our labs, where we'll get into the command line of the router, some basic commands like assigning the passwords and doing some basic verifications. So once we have some very good understanding on basic commands, we probably move to the WAN connectivity, WAN technologies, which are used for providing a WAN connection between two or more different locations. Like if you remember, just we discussed in the previous video over there, we discussed that if you have a branch office here in one location, let's say in site 1, you have another branch office in the site 2. So we need to have a routers connected on both the sides, and we need to provide a connectivity from router to switch, and then we need to provide a connection from router to router. So mostly we deal with what are the different types of WAN technologies, and this is something given by the service provider. So we'll see those WAN technologies after that. So once we understand the different types of WAN connections and the different types of technologies which can be used for providing the WAN connections, next thing we get into some basic IP address configurations, and then frame relay, introduction to routings. So the main part starts here, where we see routing, and then we'll see static routing, dynamic routing, default routing. Again, in the dynamic there is RIP, HRP, OSF protocols. We'll see more in detail on that, and then access list, network address translation, and then we get into some more switching concepts here. These are all relating to switching concepts, and then some introduction to IP version 6, and finally we'll see password reverting on routers, and then backup and restore on the routers. So it's a big list of topics. So but anyway, you get some more better idea once we get into these different types of technologies initially. So don't worry, so probably we'll get into more in detail about all these technologies. So now the first topic, we are supposed to start with something called IP address. So let's get started with IP address here. So you know that IP address, generally we say protocols. You know, there is something called protocols. So we know the basic definition of protocol. Protocol is a set of rules which a user has to follow. So protocol is a set of rules which a user has to follow in order to have a proper communication. So just like if you want to communicate with each other, we need to follow some standard language. Like we use a common language, English, which is a standard language for communication. Similar way, when you talk about network and networking, there are different types of protocols used in our networks. Like initially, if you go to earlier days of networking, like in 1970s, 80s, there are different protocols used. We got TCP/IP protocols, which was developed by Department of Defense, and then there is a protocol called NetBIOS, NetBIOS, which was a protocol designed by Microsoft for communication with Microsoft operating system devices. And we have a NetBIOS, just now we wrote. So we have some IPX, SPX protocols developed by novel machines, novel network operating systems. And then we have some AppleTalk protocols, which was developed by Apple machines, for which is used in Apple different Apple machines. So just to say, there are a few protocols. Apart from this, there's a big list of protocols. But even though we have different types of protocols, like these protocols are like different languages, like you know. So this protocol is a separate language, this is separate language, this is separate language, this is separate language. So everyone was using their own protocols for communication. If Microsoft want to communicate, Microsoft use their own language, NetBIOS protocol, and Novell uses its own language, and your Apple machines uses its own language. So everyone had their own set of protocols. But later on, they made this TCP/IP has been made as a standard language. Standard means, like English, we have a standard language which is most commonly used. So similar way, they made TCP/IP as a standard language because of one reason, because we can say internet, because the internet, which is the biggest network in the world where everyone is connected, the requirements of it, the advantages of internet. So in case if I'm using a Windows XP operating system, and Windows XP operating system is your Windows operating system, is developed by Microsoft, so it's a Microsoft operating system. So Microsoft by default supports NetBIOS, but if I want this Microsoft operating system should be able to connect to internet and it can exchange information, then my device has to mandatory support a TCP/IP protocols, because TCP/IP, the internet works on TCP/IP. So which means later on they made mandatory that even if you're using Apple machines, so when you install the operating system, by default it comes with TCP/IP protocols. So that is something which has been made mandatory by everyone. That makes my TCP/IP protocol as a standardized protocol. So we don't use any of these protocols much, and we don't really need to understand how these protocols behave, what are the different inbuilt protocols into that. So just we need to learn the TCP/IP addressing. So we need to understand different protocols of TCP/IP. If you talk about HTTP, generally we access web pages. HTTP is a protocol. When you're sending and receiving the files, FTP is a protocol which is used for sending and receiving the files. When you're sending and receiving the mails, we have SMTP protocol, simple mail transfer protocol, POP3 protocol, IMAP protocol. There are different protocols which are. So these are all inbuilt protocols inside TCP/IP. Like we have a DNS service. If we talk about DNS, DHCP, like DNS service is just like whenever we send a request, let's say if I'm like DNS is actually an inbuilt protocol inside TCP/IP, which is going to convert your name to IP address. So we'll get into more in detail about these protocols, but now the first topic which we are going to see, so the protocol which we are going to use in our network for communication is TCP/IP, Transmission Control Protocol, Internet Protocol. So now whatever the addressing, so before we get into this, so now the first part we are going to learn how the addressing is done. So that's what we call as IP addressing. Generally we call it as a IP addressing. Addressing is just like a naming given to each and every device in the network. So when you talk about a LAN or WAN, let's say I got a LAN where I got some multiple computers in my LAN, and I want these computers should communicate with each other, and also they should communicate with router, and from the router again it is connecting to some other router somewhere, and then there is another branch office over there where I got some multiple computers. So I want to make sure that the users connecting on the LAN 1, this is my LAN 1 which is in separate location, and I got a second LAN 2 which is in a different location, and I want this LAN 1 and LAN 2 should communicate whatever, it can be in the same LAN or in multiple LAN. Even if I want these users in my computers should come in the LAN, in the same LAN, should communicate with each other, then every device should have a unique address, and that address we call as IP address. So IP address is the addressing scheme given to each and every device in network. Just like every person is identified with some name, so name generally identifies a person. Similar way, every device in the network is identified with some address, we call that as IP address. Generally we call it as IP address. So that's what we are going to see, what is IP address and how it is defined, how it looks, and how we need to understand it, how the devices will understand. Anyway, devices understand this addressing, so we just need to try to understand how it is defined. That's what we are going to see here. So IP address is a logical address given to each and every device in the network, so which identifies each and every device. And there are two versions of IP addressing. We have IP version 4 and we got something called IP version 6. Okay, so let us move on with the different versions. So first let us try to understand the different versions here. Fine. So IP address, mainly there are two versions of IP addressing. We got IP version 4 and we got IP version 6. IP version 4, which is the standard addressing which is still used, which is a 32-bit address written in generally decimal format. Generally you'll find in decimal format, whereas IP version 6 is 128-bit address written in hexadecimal format. So we'll get into some introduction to IP version 6 as well. You can see this is my IP version 4, how it looks. So let me take down this here. So IP version 4, I got a sample address here. You can see some sample address of IP version 4 here. So IP version is actually 32-bit address. You can see it's 32 bits, binary digits, but this 32 bits is classified into 4 portions. Like you can see, this is my first portion and this is my second portion, the same address I wrote here. This is my third portion and this is my fourth portion, where each and every portion is having 8 bits and each and every portion is separated by a dot. You can see each and every portion have a dot. So in general you got 4 octets, or we can say 4 portions or 4 octets. The first octet, second octet, third octet and fourth octet, or we can say 4 portions. So 32 bits is divided into some 4 octets. So this is the group of 8 bits, but generally it becomes very difficult for us to understand and remember the IP addressing in the form of binary. So for our convenience we are converting this into decimal numbers. So let me just take this example how to convert binary to decimal. So I'll just give some idea. If I take this number here, so the number is 01 01 01 01 01, so it's like 01 01 01. Okay, so this is my number here. So to take 2 power values, so to take 2 power 0 here, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6 and 7. So if I just add these 2 power values, you can see 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 16, 32, 64 and finally it is 128. So wherever there is 1 we need to add those values. Like here if you see here, so this is 1, so I'm going to add 64 plus I'm going to add this 16, which is the equivalent power value. I'm going to add this 4 and I'm going to add this 1. So wherever there is 0 you don't need to add those values. Wherever there is 0, no need to add those values. So now if you just add 64 plus 16, it becomes 80, 84, 85. So the equivalent decimal value for this is 85. Similar way the same calculation here, 85 dot 5 dot, you can see it's 191.1. So in general the IP address looks like this, but the computer understands only in the form of binary. So this example will give some simple idea on how exactly IP version 4 address looks. Okay, so now IPv6, you can see here this is one sample address of IPv6. It's actually 128-bit address, which is written in 8 portions. Each and every portion is having 16 bits. Like that we have 8 portions, 1 2 3 4 5 6 7 and finally 8. So we got 8 portions in total. It's 8 into 16, it's 128-bit address. So we'll see more in detail about IP version 6 later on sessions. So our main focus in this class is to make sure that we understand the IP version 4 addressing. Okay, so now we confirm that from these examples we can confirm that okay, each portion is not going to have more than 8 bits. So each portion will have only 8 bits. So that is something we can confirm from this scenario here. So fine. So now from this scenario we make sure that there are 8 bits in one portion. If you count, minimum number is 8 zeros. You can see here 8 zeros is the minimum number and the maximum number is 8 ones. So which means if you count this, so the range of IP address starts from 0 to 255. So this is the range of IP address. So IP address range is just from 0 to 255. Anything more than 255 is not present in any IP address So if you want, you can probably try assigning the IP address on your network computers. Like you can go to network places, you can go to my adapter settings, and you can just check out. So anyway, I'm not using this LAN card, so I'll go to these properties. So TCP/IP properties, if I just try to type 100 dot, if I just try to type 256, you can see the message here. It says 256 is not a valid entry, please use the values only in between 0 to 255. That is what exactly IP address range. So in general, the range of IP address is only between 0 to 255. So that's what this example says, that a range is from 0, starting from all zeros, and ends on all 255s. So this is the range of IP address in general. And again, this range is further classified into 5 classes. And they said that 0 to 127 is A class, 128 to 191 is B class, 192 to 223. So let me write down it very clearly here. So now they said, so A class, B class, C, D and E classes. And they said that 0 to 127 is A class, 128 to 191 is B class, and 192 to 223 is C class, 224 to 239 is D class, and 240 to 255. So the first thing in IP addressing is, whenever you see any address, you should be in a position to identify the class. Like if I take an example, I'm going to write 192.168.10.10. So this is my IP address. So now if I ask you which class this IP address belongs, means simply we need to see the first portion, because the classes are divided based on the first portion. 192 comes in between the range of C class, so it is a C class address. Similar way, if I take an example, so you should not never see this. So remaining 3 portions can be anything in between 0 to 255, the remaining 3 portions. But if the first portion is in between 0 to 127, you have to understand it's a class. If it is in between 128 to 191, you have to understand it's a B class. And anything in between 192 to 223, we need to understand it's a C class address. Anything in between 224 to 239, it's a D class. Anything in between 240 to 255, it's a class E address. So only you have to see the first portion, because the classification is divided based on the first portion. So let's take some 2 more examples to have a more better understanding on this IP addressing. Like if I write some address 150.12.10.10. So if I just say this address, so now if I ask you which class this IP address belongs, so we just need to see only the first portion. And 150 comes in between the range of 128 to 191, which is a B class address. So don't say this, okay? So this can be anything. So don't think that it is A class, because this is range, so it's not correct. So this can be anything in between 0 to 255. So similar way, one more example. If I say 100.10.10.10, so if I just ask you which class this IP address belongs, so 100 comes in between the range of 0 to 127, so it's a A class address. So these numbers can be anything in between 0 to 255.